Okay, welcome to web scraping with Python. Today we'll be diving into web scraping. You should have a little basic Python background, and then we'll handle how to do the actual web scraping in Python. We'll show you that code and how to do all that, and a couple things else along the way. The project today I will be doing it in Replit, just so anyone following along can do it easily. So you can make a free account. It's an online IDE, so you don't have to download anything and install anything. So you can just go to replit.com, make an account. I have a project set up, but if you need to set one up still, once you get into the account and you open up Replit logged in, just go to create a REPL project. We'll let this load, and then what you'll do is just choose Python. You can type it in if you don't see it in this box, and then you can just give the project a name and then just click on the create button, and then you'll essentially see what I see minus the files that I already have in the file system with this project. Along the way, we'll be following along with the handout, so you can reach out to me if you still need that. See what we're doing. In the handout is all the links to how to do this stuff if you need a second lesson or a full lesson, because we obviously won't get to everything today, along with links to Replit, and the website that we'll be scraping is in the handout as well. We went to replit.com. So what is web scraping? Just in case you don't know, it's simply the process of extracting data from a website using a programming language. In this case, Python, though lots of languages can do it. And the reason that we want to be able to do this, you might need to do this, is that some websites have data available as like file downloads or something like that. You can download a spreadsheet. We even download images and videos because you can web scrape all types of things. But even if you have like a download button on a website, you might need to press that button tens or hundreds of times, depending on how much data you need. And then if it's something like stock data, when you want to get maybe 1,000 points of data every single day, that almost immediately becomes too time consuming to simply do by hand, go to the website manually, copy and paste all the data and put it in a file. That's way too much. So if a website has its data simply in the HTML, we don't have a download button. You could copy and paste it, but what we can do with web scraping is code in Python, go to this website, pick out these specific pieces of text or data on the website, and we'll need a little bit of HTML knowledge to do that. And then it can automatically grab that data. We can do something with it if we want, or we can just immediately save it to a file like we'll be doing today. A lot of people ask, like, is web scraping allowed? Is it legal? It is legal, though sometimes websites will just stop you. They'll set up automatic blocks and things like that. And we'll just talk a little bit about why that is. One, web scraping is the exact same thing as you and I just manually accessing a website, but instead of us opening up Chrome, typing in a website, and telling Chrome to give us that website, Python is doing that, and it's doing it programmatically instead of us using the mouse and doing it in real time. And the difference between us doing it and a machine doing it, Python doing it, is that a human can only access a web page really slowly. They can only click a few pages at a time. But if we automate it with Python and web scraping, you can request hundreds, thousands of websites, as fast as Python can run. So the real thing, the dilemma is this hits a company's or a website's bandwidth. Website traffic costs a website money. So if they have, humans going to the website, but then they get bogged down by a bunch of bots and all these types of things, that's going to damage them and it's going to cost them. So depending on all that, what they want to allow, they might ask you not to web scrape. They might automatically block you. In some cases, it'll just be open to web scrape. You can web scrape lots of websites. Just kind of have to check to see if you can, just test it out or do a little digging to see if it's allowed. Ahead of doing the actual web scraping, because the whole point of this is to be able to extract data and then save it and things like that. So we kind of have it to use again, to kind of pile up and then look at a whole big data set. We'll actually be beginning with finding out how to open files and edit and save files in Python. And then once we know how to do those little steps, we can actually look at the web scraping once we know how to, save the data that we have. In the handout, I just have some command lines, commands. Let's see what else. Okay, so let's get into Replit and we'll go along. I won't always show the slideshow, but if you need it, you can ask me. Contact me to get it. Okay, so to begin, we'll just be making, let's just make a dummy file, a little text file in Replit so that we can go and open it in Python, and then we'll edit it and then we'll save it again. But just to begin, we will just kind of make one manually. We could in Replit add a file with the GUI, the graphic interface system, by adding a file, doing this, and then adding some text in the edit window, but we can actually do it in the shell. So I'm going to show you guys how to do that just as a little bit of added practice. So just a couple commands. pwd, that's going to print my directory, the kind of location that I'm in now. We can just see I'm in web scrape 1. So I'm just kind of at my main location. I'm in these files. That's showing me my kind of file path. If I want to see what's in my location, I can use the command ls. That's going to list all my files, and we can see, I can see my final and my main.py and these couple files. So I'm seeing all the files in the location. And let's go ahead and make a file in the shell. Touch is going to make a file, and then I just give it a name and an extension. I'll just call it demo.txt. We can see when we do that, it automatically pops up, and we can then come in and put some stuff in. That's not supposed to be in, but let's go ahead and edit it in, continue to do stuff in the shell. So let's add some lines to it. So I'm going to use cat and then the little caret symbol and demo.txt. And when I send in this command, it's going to let me add text to it as I want. You can see as I add it in the shell, it's adding it in the actual file. I'm just going to add a couple lines as a demo. To kind of get out of this edit mode, just click or type Control D. Control D will kind of say I'm done putting stuff in the file, and I'll get back to my shell command line. And then if I want to view that file in the shell, I can just do cat demo.txt, and it'll show me everything I typed. So now I have a file. We only need a little bit of text because we just want enough to be able to see once we open it with Python that we have that text. So this is good enough for this 1 to 5 like this. Just one last thing, let's make one last new file. I'm just going to call it files.py because in this file, we'll talk about opening, editing, and saving files. So I'm just going to make it with the touch command again, and then we'll go ahead and move into the edit window this way so that we don't have to keep doing it in the shell, because usually we wouldn't keep editing in the shell. This is what we'll be doing, but I'm going to kind of explain everything that we do. So one, we'll have to open a file and kind of grab the contents out in Python. And then once we've grabbed that data, we just have a typical Python string or maybe a list, and then we can apply the basic Python that we know. But this is going to be how we can open a file in Python. Hey, welcome. I only just began, so you can go ahead and catch up. I sent out the handout and these kind of files as well. Let me know if you have any questions as you settle in. So with this, I'm just explaining how to open a file, and we'll be editing it and saving it in Python. And then once we know how to open and edit and save files in Python, then we can go actually web scrape, because we'll want to, obviously save the stuff that we web scrape in the end. So that's why we'll be beginning with this. So with this new command, this line is going to let us, it's a special line. We probably haven't seen it from Python basics, but this is going to let us open a specific file that we have in the file system next to us. So I'm going to say with open demo.txt. This little flag means I'm in read mode. I'm just going to kind of read only it. I'm just going to pull out the text, but I'm not going to change the file inside this code block. And then this name, you can give it any name you want. This is kind of what people usually give it, just to let us know again that I'm just read-only mode. I'm going to pull some stuff out, but I'm not going to actually touch the contents of demo.txt as it is now. And then we'll be indenting just like any loop, any function to kind of indicate what's inside this with open line. And the reason that it's indented is because as soon as we finish these indented lines and go on to the next code down this way, we'll have left this kind of code block, and then we'll automatically close the file. Kind of behind the scenes, we have to open the file and close it. So this just kind of does both at once. So that's why it's kind of indented in this way. You can also, without indenting, open a file, do some Python code, and then close it. But this is the easiest way. It kind of handles it automatically when we leave the code block. And then what we can do is let's actually do I'm going to type this out. So with open, and then we can say we want to grab all the text of demo.txt. So what we'll do is we'll save it in something called all text, and we will attach to the, basically this is the file that we have, and we'll attach this special function, this special method called .read, and that's basically going to suck out all the content of demo.txt into all text. Pretty simple. And then we can just check this. We'll come back to the shell. We'll run files.py, and we can see we've basically extracted demo.txt, the 1 to 5, with just these two simple lines. Just basically grab everything, save it, and then we just print it out in the second line. We can kind of check what's going on, just if this is new to us. We can see kind of what all text is, like what kind of type of object, and we can see what type of object this like file is. So all text, just basic Python at this point, it's just a string, so you can do indexing, .replace, you can find matches and things, all the stuff we know with strings. But this second thing, which is basically the file itself, we can see it's this special type of object. So we can't just like do anything that we might know about till now. If you want to do anything else with it, you might have to look up some additional things to be able to handle this. So that's pretty easy, just grabbing this stuff out. And then we'll just take a look at one last thing we can do. Instead of just reading all of the file at once and just getting one big string, we can actually use the read lines method, and we'll change this to the lines. And what this is going to do is, instead of giving us a single string, it's going to extract each line as an element in a Python list. So that kind of helps us break up the file depending on how we need it. So then we can just do a simple loop for lines and line, print line like this. And then we can see we get that. We'll just do a little check. We'll check the type of the object lines that we saved. And we can see it's a list. The one thing we'll notice is that we have like additional spaces between all of these, even though we don't have these spaces in like this. And that's because when you use read lines, it's automatically taking each line and also including kind of the new line to jump to between lines. So you get like an additional new line at the end of each. So what we could do to handle this, and we'll see down the way why we'll need to do this again, is we can use the .strip string method, which we talked about in Python basics. That's going to remove any leading and trailing white space, including that new line, that /n. And now when we do it, we can see we get just the text content of the files, each as an element, and not like the kind of doubling of new lines if we don't need that. So pretty easy to open at least the text file. When you get to like opening CSVs and Excel files, if you want to, you'll need some additional methods and things, but with just a plain text file, pretty easy. You got .read and you got .read lines, which will give you a list of each line of the file. So this pretty much handles the last kind of drawback if you took the beginning Python class with me. We talked about functions, which was a reusable block of code we can use anytime we want, again and again. We talked about loops, and that basically lets us do actions as many times as we want, not just on a single data point with things. So we have that kind of ability to do multiple things. And then we obviously have objects. And the one drawback we had up until now is basically data input. With loops and functions and objects, we could make millions of data outputs, but to input data, we kind of all had to type it out manually in Python as elements in a list or a long string, something like that. But if we wanted to do some Python on a whole bunch of scientific data, like financial data, that would have taken a while to copy and paste all that data into Python and put all the quotes and the list punctuation like that. But now that we have this, it's pretty easy to imagine we could have, instead of demo.txt, stock data.txt, and on each line, we could have some stock data. We could have a CSV. Each line is a single stock, and then between each of the commas, specific stock data to a specific day. And then we can grab it all, and inside this with open, as soon as we get the data, we can clean it up a little bit, save it, do something with it that way. So now that we can pull data from a text file, you can do almost anything. You can take a lot of data and do stuff with it. And we've already known how to output a lot of data with loops and strings and range and things like that. So opening a file, pretty easy. Now let's just do the opposite. Let's take some data and save it to a file. Equally easy, pretty much. So let's do this. We'll keep this. And what we'll do is we'll, again, take up this data with open, and then we'll change the data, and then we'll save it to a new file to see how to do all that. So we can keep the same code that's taking or extracting the original data. And then down below, we use the same line with open. But this time, what we need to do is, actually let's edit the data a little bit. We have lines, so let's go ahead and just edit the data. And by the way, once we leave this code block, this indentation to this with open, we kind of close the file. But since we save the file contents as lines, that's just a plain old Python list, we still have access to that data, even though we closed the file because we saved it in this kind of Python session. So we can just do anything we want to it. So what I'm just going to do is I'm just going to add, instead of having 1, 2, 3 to 5, I'm going to make it line 1, line 2, line 3, just so we can see the change. I won't explain too much what I'm doing. Just kind of loop lines, and each element, so I'm going to index into lines as I go, line 1, line 2, line 3. And I'm just going to change it a little bit. So I'm going to say update lines index 0, index 1 to be now line plus that element of the lines list. So just changing it a little bit. Let's go ahead and actually just check that to see that it changed. Comment this out. And we'll just check that. You can change it to anything, but yeah, we can see now I had 1 to 5, and now I have this line 1, line 2, like this. And we can see I still have that that /n. So maybe we can actually take it out again. Let's see if that does it. Yep, so that does it. We just stripped out the new line at the end of each of them. But now we can go on to actually the main thing, which is saving it to something else. We could have changed it any way we wanted. So with open, we use this again, and we'll open it up. And the initial input that I have is going to be the name of the file. And if you give it a name that doesn't exist, I obviously don't have new demo.txt on this side. If you give it that type of name, one that doesn't exist, it's just going to make that file. So this is fine. If we used demo.txt, it would basically delete demo.txt and replace it with this new one that we make now. But usually when you open files, edit them, and save them again, it's best to keep that original data untouched, just in case anything happens. So I'm going to save it in its own file. And then the one thing we'll have to change is instead of being in the read mode, we want to be in W so that we can write to the file now. So we can see the difference between these two lines, basically just the end. And I'm just gonna, again, I can choose this name. It's just basically an object name, but I'll just name it so that I know what I'm doing. And now we want to write to this file. And we want to do that kind of line by line. So I'm just going to kind of loop my data. So line in lines. Each time I get a line in hand, I'm going to write to the file. We can see dot write pretty much like dot read or dot read lines. So pretty simple methods. And what I'm going to write is I'll just give it kind of one object. I'll give it line, and then we'll see what this does. This should be all that I need now. This is all that I need, and I just looped to do it as I wanted. So you can see I ran the file and it immediately popped up. And now we can see I have it like this. We can see I took out that new line and it looks like I actually need it because I see that dot write does not explicitly jump to a new line each time you get it. So let's actually go back and take this out. Save. We'll play this again. And we can see when we get to this, it basically just deleted the old new demo.txt, gave it the new update that we just have. So now, yeah, we made a new file, opened it, changed it, and saved it back again to something else. So now that we have these basic tools, that's all we need to go onto web scraping now, because now we can actually save that data. Just to begin, let's do a little bit of HTML review because that's what we'll be looking at, because we'll be extracting from web pages. So we need to know a little bit about HTML. We'll see kind of step one of web scraping is just kind of requesting the whole web page. So we kind of will be kind of downloading a .html file in Python, and we can just kind of easily get the whole text content of the page. But obviously we'll be wanting to extract specific data points on the page. What we'll be using today, we have a website that basically has all the Aesop's fables. So we'll be looking at the table of contents, and then we'll want to kind of extract all the fables at once and kind of download it that way, since this website doesn't come with a download button. So we want to not extract everything, but basically just like the title, the fable text, and this thing at the bottom. We don't want this image, the logo, the back button, the next button. So we need specific things. So pretty simple. HTML is kind of a nested shape. You have elements inside of elements. So like with the body of a page, that's the main text content of an HTML object. So if I want everything, I'm going to, in a few minutes, we'll see how, select, the body, because when I select the body, it selects everything inside of it as well, not just the body, because we can see from both diagrams, all of this is kind of sub-elements of body. So it's going to extract all of that as well. If I just wanted maybe the P tags, which is, the paragraphs, I could just select P, and then I would skip, this bullet point list and the headings and things, and I would just skip that. If I wanted to get just these bullet points, I could select I could select the list item with the LI, and I would select all three of these, but I could also select the UL, who just, the list element, and it would select all the nested list items within that. So that's the main thing. I won't even get too much into this, but you can take a look back at it if you want to go beyond what we do in this class. But the main thing is we'll be selecting things because everything inside of that element is what we'll want. And we'll see what that means once we actually, get at it. Okay, so one, we just have to do one little quick setup step. So in Replit, what you'll need to do, because this isn't kind of built in Python, it's an additional module. So we kind of need to tell Python to download it and explicitly tell it we'll be using it. So in Replit, how you can do this is you can come to the packages button on the left, and you can just type in beautiful soup. That's the name of this web scraping tool, one of the best ones. You can see it pops up at the top, and you would click the plus button to install. Mine's already installed, so I see the delete instead. But all you have to do is just click the plus button. It might take a couple seconds to load it and all of that, but then you can use beautiful soup in this Replit project. So that'll be what you need to do anything beyond this if you're following along now. And so once we have that, we'll come back and let's go ahead and make a new file. I'm just going to call this scrape.py. And let's just get step one out of the way. It's just a couple lines of code, I think maybe even less than 5, just to get the whole website and have it in Python. And then the next couple steps will be to select out those specific bits that we want, but it's pretty easy to just get a website in Python. These steps up at the top, these basically tell Python what modules that we need. Again, we just added one as a package, but in this file, we need to tell Python, go and use those. So we need to say, we'll be using beautiful soup and we'll be using requests. So we'll need these up at the top. And then we just need one data point, and that's the web address of the website that we plan to scrape. So with this, I need to be, we'll go ahead and begin on the table of contents. So this website is just read.gov/asop 001.html. So I'm going to go ahead and just cut that and put it in. Step one is what site we want to scrape. And then step two is pretty easy. I'm going to get my page and save it as an object. And the method with a function to get it is requests.get. I just put in my, my web address object to say which website to get. And then this is basically all that I need in a way. And we'll see what it looks like. So we can see in the beginning page doesn't look like anything useful yet. It just says response 200. If you know anything about websites, that basically means we successfully got the website. So this is actually like the status code. We got the website. But what we can do is now we can go ahead and use Beautiful Soup to actually see the contents of the website. So I'm going to call what we make soup. This is going to be the website or the web page itself. And I'm going to say, use the Beautiful Soup function. And I'm basically going to say, take the page's content, its content attribute. And the second thing I just need to say is that it's an HTML file. So I just need to say we need to analyze it as an HTML file. So that's the two things that I'll need. And then we can print out the soup instead of the page with the page response in this case. And once we get that, we can see pretty fast. It's just displaying the HTML in my shell now. Let me magnify this a little bit. So let me go up to the top. This website I chose because it's HTML is pretty simple as you can get, not too complicated. So let's go up to the top. You can see doc type HTML. We can see the title, Aesop's Fables. a couple things up at the top, but then we just see the table of contents as HTML. So we see kind of the link and then the actual link. This is the link text and this is the actual link. So it's not too bad of a web page. And then some stuff at the bottom as well. But now we have soup, so we just have the whole website as kind of a complex Python object, and we can do a bunch of stuff with it now. A couple of built-in things that we can do, like we can do, since we have one title to a single HTML page, that's like a built-in kind of attribute. So if I just say .title, it's going to find the title of my soup, which is again just Library of Congress, Aesop's Fables. And we can see that's what this is up at the top, the kind of tab title. That's what it's extracting at the moment. And then we can see it got the text, but it still has the HTML, the tags, the title and /title at the end. So one thing that we can do with anything from now on is get what we need, but then add on one last additional method, and that's going to be the get text method. And this basically takes any little chunk of HTML that you get like this and just strips away the HTML. So now I just have the text, Library of Congress, Aesop Fables. And this is going to be useful when we extract all the table of contents. We'll cut off the HTML. When we get to the fables themselves, we'll just get the text and download it to a text file. We won't have all the HTML with it. So this one we'll keep using. This one was just a little demo. So what we'll need to do now, obviously we have the whole web page, HTML and Python. Now we need to go and select out the specific things that we want. So we want all of this stuff in the middle, which is the table of contents. And this HTML is equivalent to what this is. And so we'll be using the inspect element to see how to get just this table of contents. Oops. So on my web page itself, I'll leave Replit a quick second. I'm going to right click. You can do this on Chrome, Mozilla, Edge, anything. And you should see something that says inspect or inspect element. And what this does is it's going to show me what I just saw in Replit, the HTML behind the kind of displayed final product page on the left. So we can see, we can do it again. When I inspect on any specific thing on this side, it's going to show me the equivalent HTML on that side. And when I click on something on this side, it's going to kind of highlight what is on the page that this text or this HTML makes. So the kind of idea going on from now is we just need to find the specific HTML element in all of the things inside that element, its sub-elements. That's the stuff that we want. And then we just need some way of specifying that piece of HTML, and then we can go ahead and pull it out. So to begin, let's just find what we need. Like I said, we don't want all this stuff at the top. We basically just want this single list with just the titles and the links kind of hidden behind them. So we'll kind of get this and skip everything at the top and the bottom. So if we go back to inspect, we can just kind of click around. We see this div with ID page. That looks like it's kind of everything maybe, because we don't want this stuff up at the top. This one looks promising, div ID TOC as in table of contents. So that looks like what we want. If we go down and click it again, yeah, we can see that's just what we want. It's just highlighting the list itself. So this is exactly what we want. We want to go into div ID table of contents, and then we'll be able to pull out what we want. And then one last thing we'll need to do is we don't want to just select the table of contents. We want to select a specific thing inside of it. We want all of these link tags. So I'm not just going to say pull out the table of contents ID. I'm going to say pull out all of these A elements within div ID table of contents, because this is what I want. I want item 1, which is the fable title itself, kind of that plain text. And then item 2 is kind of the link to get to that page. If I click on this, it takes me to that fable. And we'll use this when we web scrape to dynamically go to each page one at a time and download the page all at once. So let's go back to Replit and just see, how we can do this. Just to mention, as I go, I'm going to comment out all my print statements, because as we begin to do this, we'll be looking at 150 web pages at once. So if we leave these print statements in, this console is going to get slowed down by printing out so much all at once. So I'm just going to comment them out as I go. But next, what we need to do, so we'll need to select all the links within the table of contents. So what we can do is we'll say links, we'll save something in something called links. And then we'll say, take my soup. And again, that's my whole web page. And a new method that we had is .select. And this is basically going to do what CSS selection does, if you know that. It's going to let us choose specific components of the web page, like all A tags within the ID table of contents. And then we'll have a list of just those things that we just saw. So inside .select, inside this method, I'll put a string, which is the selection that I want to make. And again, this is exactly like CSS selection. So what I'm going to do is say inside ID table of contents, get me all of the A elements, all the link elements, and it's going to save it in a list. .select is going to give me back a list of all the items that match this. So we got that. We'll just do a little bit extra, then we'll print it out to see what it looks like, what we want. So I'm going to make a dictionary called titles. And what we'll want to do in this is the key value is going to be key, this plain text name of the fable. So, the fox and the pheasants is going to be the key. And then the value I'm going to save as this link, this relative link. And we'll talk about how to make the full link in a second, but that's what I want to save. I want to save all the couples, fable, and its link. Back in this, I can just say, I have links, we haven't looked at it yet, but it's just a list. So I'm going to say loop list, and I have, I'm going to call it A because it's a link. So for link and link, or for A and links, I'm basically going to make a key value item in my dictionary. So I'm going to say add a key to titles, and my key is going to be a.getText, and that's going to give me just the plain text, not with the open A, close A tag. So that'll give me the old line instead of A, the old line, close A. So that'll give me that. And then its value is going to be the href. And this one is a little special. I'm kind of pulling out the specific attribute, which is this href link from my A item from links. This is something special that .select gives me. But we'll see in a second what it looks like in the end. And you can play around with it to see it at each step. But now we can kind of just look at it as a whole. So print titles. Hopefully we didn't make any typos. And we can see, we'll scroll up to the top. It's printing out, we can see it's printing out a dictionary because we see the squiggly brackets. That's what we made. And we can see key, fable 1 and its link, second key, fable name and its link, and so on. So now we've extracted the kind of table of contents. That's in a couple ways, because one, we just want to now save a text file that's just going to be the table of contents, because we want to kind of download this whole website. So we'll want the table of contents as its own file. But this will also be useful in accessing each of these pages one by one in code. Instead of running this web scrape on each file individually, we can get to each of these web pages all in this file all at once. So we want the link as well as just the list of plain text names in the end. So let's go ahead and just do that step one. Let's just save one text file. This one's going to be pretty easy. We just want to make a table of contents, and we'll just use just the keys of this dictionary to just make a plain text list and save a new file. So we'll save the table of contents. I'm going to do a couple additional steps. I'm going to, on the side, I'm just going to make a place called ASOP, just so I have some place to put all these files, so it's not all in my kind of main level. I can kind of collapse it so it's not taking up so much space. So I'm just going to say make an ASOP box on the side. And then to be able to save to that ASOP, I'm just going to add a couple additional steps that we didn't do the last time we saved a file. So we need one last module. This one is the OS module. And what we need to do is not only specify, we want to save with open table of contents.txt, but we need to say the save path to get to it. We don't just want to save it in the main level. We want to get to this ASOP box. So this is what this save path is doing. And to kind of know that path, I can come to this. And if I do pwd, like we did at the beginning of the class, this is my kind of file path that I'm at right now. So I can kind of copy and paste this. Actually, let's go one last step. Let's list. We can see I see ASOP. So let me cd to ASOP to go inside of that ASOP box. And now let me pwd, and now I get the full thing. I could have just added /ASOP, but if I do it this way, I get it without the possibility of making a mistake. Oops. You can't copy and paste from this with the Control-C, so go ahead and right-click to get it, because Control-C is its own command in the shell. Okay, so we got the save path. Let me go back by cd ... so I can get back to my main level. You'll have to do with that, or else you won't be able to run scrape.py. So definitely do cd ... to leave ASOP. And now we can go ahead and finish up this. So we know the save path. My second step is just going to be my file name, and that I'm just going to name table of contents.txt or just toc.txt. And now I'm just going to combine those. So I'm going to say the whole file is a bit of a fancy function, os.path.join. And it's basically saying, take the path and take the file and combine them into one object. And now what I can do is what we saw a little bit ago with open. I want to open the file. Since it doesn't exist, it's going to make it. And it's going to make it inside ASOP. And I'm going to be in W mode. And this time I'll just call it doc, because you can name this anything you want. So in my document, what I want to do now is add all the titles as its own element on a line. So I just need to loop my titles dictionary that I made. So that's pretty easy to do. Key in titles.keys. I just want the keys, so I don't need to get both key and value, that kind of loop. I can just get the keys. And I'm just going to do doc.write. And I'm going to do key plus, and I'm going to add a new line at the end because we saw it doesn't do that automatically. And now let me go ahead, come back this way. Run that. We see I get all my print statements again, but what we saw is toc.txt just popped up on the left. And if we go inside, we can see I got all that I wanted. So I have all my table of contents as a single text file. Each one is on its own line. If we wanted to, we could, kind of add anything in this we want. We could have added a little bit at the beginning. We want to modify it like that and then write it again. We can see what that'll look like. So you can kind of do anything you want when you set this up. And now we can see, it looks like I missed the new line, but you can kind of add stuff to the beginning, stuff to the end as you want. Okay, so that's basically all that we do with web scraping. We just web scraped, even though it was a pretty simple one. But now we'll take it up a notch because usually when we web scrape, we want to do multiple pages at once. So we'll do a little bit to get to each of these Aesop fables. So we'll kind of dynamically go to this one, and then this one, and then the next one. And then what we'll do inside each of these is look at how to select this title, how to select this bunch of text, and how to select the kind of a little bit at the end about what the fable was about. Okay, so let's go, just keep moving down the file. So one, we notice, if we take a look at this dictionary that we made, the key is the fable title. So we've used that with table of contents, but the value we still have yet to use. And we could see it's like the name of an HTML file. And if we take a look at this, we can see it's this bit of the link. It's kind of a relative link relative to the whole base web address, but we need to actually add this to each of those title values that we have, because this is kind of incomplete to Python. We need to say, go to this website plus this relative link at the end. So we need to kind of make a complete web address with the relative link that we have in that dictionary. So what we can do is we'll just say base is equal to, and we can just come in, copy this, and the base is going to be just this bit, that's the base. And then each time we go to a page, we can just dynamically add on this value, and then we can add on, the next value, and this is how we can kind of do it dynamically. So the base is equal to that. And now what we need to do is, like we said, we want to go to each page one at a time. So step one is just going to be making a giant loop. And inside this giant loop, we'll do all the code that we do to any single page one at a time, and eventually all the pages consecutively. So I'm going to take my titles dictionary that I have. This time I want both items. I want the key and the value. So I want the fable and the link. So I'll loop using .item, so I get both of those back in my loop. What was that? And then what we'll do inside, let me just check to see what we have. So I'm going to do link. It's always nice to just check as you go so you don't do too much code and then find a mistake 5 lines ago. Again, comment out everything above. And let's do this again. Yep, so we can see this is what I have now. So this is pretty useful. We can imagine all the code that we do from now on, we can do to page 1 or page 2. And then once we have it set up once, it'll do it to everything else automatically that way. So this is good to go. It's what we expect. So let's do what we did in the beginning. If we take a look at the beginning, what did we do? We just requested a page given a web address. And then we kind of soupified it to get that nice object that we can pull stuff out of. So we'll do these 3 steps again. So step 1 is going to be request the page. So again, page is equal to requests.get. And this time, pretty easy to get it. Just the base plus the link. And again, it's going to be the base. And then each link is going to be something like this. So combined, they make the total address of that web page. So base plus link. We can do, you can imagine as you set up a huge project like this, you probably want some like bug proofing and checking to see that everything is going okay. So I might add using the .ok method of kind of the page object. Basically, if I don't get the page back successfully, maybe I go to a page that doesn't exist or something, or my Wi-Fi gets shut off, I'll get a little message. So I'm just going to put that little bit in because that's something you'll want to add in big projects. But then the second thing is make some soup, beautiful soup object, get the page.content. And then again, it's going to be HTML. So we'll just denote that in the second thing. And then what we'll want to do We can again, we'll just print the soup. And now what I'm going to do actually is at the bottom, I'm going to add this break line. And this is basically going to let me run my scrape.py file without checking and running this code on all, 150 pages. What it's going to do is it's going to break the loop that I'm in. So it's going to do one web page, just check one, so my print console isn't running with all this text, and then just stop at one page. So let's go ahead and check this to see that we see some, some nice new HTML. It's not the table of contents. It's actually not that big at all. But if we take a look, we can begin to see, this looks like the text content of, the frog and the ox or something. We'll see in a second, but we've gotten it successfully, so that's good. So let's go ahead, and now we need to do what we did again with table of contents. Go to the HTML itself, and we'll leave Replit and go to the actual web page and use inspect to get it nicely, and basically see what we want and how to get it. So thing one that we want is just this title. We actually have this from this dictionary that we've been looping. We have this because we have the table of contents, but just to practice, we'll get it again to practice one last selection. So I'm going to inspect that title that we want on any of these given pages. You can see that it found it. And what we'll do, we can see it's just an H1. And it's below ID page, but we'll just see, maybe we can just use H1 to select it. Most web pages do and only should have one H1. It's kind of supposed to be unique, so we can confidently just say select H1. We should only get one, so we don't need to be too specific. What we can do is say, we want to grab the title and we want to get just its text. So let's say, go to soup and select, just the H1. And then like we talked about, select gives back a list. Previously, we kind of looped that list when we got all the table of contents. But now we know we kind of just expect and only want one thing. So we don't need to like loop a list or anything like that. We know that the thing that I highlighted equates to a list. That's what it's going to make. So just at the end of it, we can just index into the list that will be made and just get item 1, index 0, get the initial thing that it finds. I probably won't have anything else anyway. So we'll say get item 1. And then also we can just keep tacking on stuff to the end. We'll say of that H1 that you get, strip out that H1/H1 tag and just get the plain text itself. And we'll check that at the bottom. And I'm just going to put some breaks so we can see it in the console. So we selected H1, come back this way. Take a second to load. And yeah, you can see we got it again. And again, we already had this, but just to practice again. So this we'll come back to in the end once we do the next couple steps, because we'll use this to basically do doc.write title, doc.write fable text, and then the last thing as well. And we'll save it all to a file, but we'll just kind of leave that at the moment and go on to the next steps, which is to get fable text. Let's go back to any page. I chose this one because, like most websites should be, each page is going to be set up mostly the same. The kind of HTML and the IDs and classes should all be consistent across the same type of page. So when I find the kind of HTML that includes the fable text on fable 1, it should be the same on every single one from now on. If it's kind of like a junky website, you might run into issues that it's not all the same, then it'll be extremely difficult, if not impossible, to web scrape, because each page will need like a custom web scrape Python file. But we should be able to find, in most cases, something that applies across most pages of the same kind. So let's inspect on this text. If we inspect it'll show us in this HTML. And we can see it's all included in just p tags. So we'll probably select a p tag, but we don't know if maybe this is a p tag, this is a p tag, maybe down at the bottom, this is also in a p tag and this stuff as well. So let's be a little bit specific, not just the p tags, but maybe just the p tags within this div ID equals page. If we go all the way down, we can see that it excludes most of the stuff. It excludes the stuff at the top and the bottom. It doesn't exclude this thing, which we want to be different. But if we go ahead and inspect this now and kind of look ahead, we see this isn't a p tag, it's actually a block quote. So that's what we'll do next. We'll select the block quote to get this. But with these guys, we can just say, select all p elements within ID page to get this text. So we'll go ahead and come back. We've done these steps a couple times now. So I'm just going to say, save in lines the stuff I select out of my soup. And I'm going to put within page, find all p tags. Again, this is going to give me a list. And we want to get the text and clean it up a little bit. So let's actually loop this list lines and clean it up a little bit. So I'm going to do that this way. So I'm going to say lines is equal to, and then let's clean it up a little bit. Let me type this out, and I'll explain what it's doing. So this is actually basically, it's called list comprehension, what I just did. We didn't do it in the Python basics class. It's going to be exactly equivalent to this code, which you would know from that class. Oops. Let me just check that this is up to date. Okay. Okay, so list comprehension is basically just an abbreviated loop. So we can see it kind of looks like a loop. It's inside these list brackets. So it's making a new list. And what it's basically saying is take lines, the old lines, give me back each line one at a time, do this to each line, get text of each line, and then kind of implicit in what I just highlighted is append it to the list lines that I'm making now. You don't have to get that, right now, but definitely look it up because you'll definitely see that, out in the wild. People do list comprehension all the time to kind of chop out this bulky code. It's something so simple they usually use list comprehension instead of setting up a whole loop like this. But this is just what I'm doing, just stripping out the HTML on each line of lines and then just saving it back in a list, which I just also called lines. So it's actually deleting this old lines and making a new one. And then I'm going to change the name at this point. So I'm just going to say lines is now called fable lines. So that's going to be my step 2, get the fable text or get the fable lines. And we can actually check that. So let's print this out, comment this out, comment this out, and let's see what that text looks like. Yep, we can see we have a list. We see the list brackets. Each line is its own string inside of it. And then we can see the comma, and then we get to the next line. If we printed lines at this point, let's do that, and we can see them kind of side by side. We can see up in this list, we still have those p tags. So that's why we had to do that little cleanup step. Okay, so that is step 2. That's probably the most difficult one. This is an immensely difficult project, but we just have one last kind of data extraction step. We saw that with the block quote, we want to get that little thing at the end. So we can do one last thing, again, using this soup.select method that we got. So I'm going to say of my soup, which is again my whole page, select out of it just any block quote element. So I'm selecting just the block quote. And we saw that in these pages, we just have this block quote. If this was a page with a complex HTML tree on the side, you might not be able to just say get block quote because it could have multiple block quotes on it. So it's usually not as easy as just saying get a specific element. You would usually need to specify with a class or ID, which we did with the last ones. But I think with this one, block quote, it's the only one. So get that. Again, we'll clean it up a little bit. So we'll say it's selecting block quotes. It gives us a list, even if it only finds one. We expect only one, so we'll just say, give us that initial one. And again, as always, just give us the plain text because we want to save a plain text file in the end. And then we can print it out. Let's see what just happened. Oh, so this, oh, I didn't actually save it. So you see, I did something, but I didn't save it in an object. Okay, so now it should be fine. Okay, so now we have, just as a string, just as plain text, that little bit at the end of this tail. And eventually when we take off the break, we'll get them from all of them at once. And let's actually do that. Let's take this away. We'll just keep this one print statement, but just to see if it runs through all the fables without crashing or anything like that. So let's do this. And we can see it's going, it's going, it's going. It's actually not this slow. If we took out all the print statements, it would probably finish up in a second. But when you have print statements in even only one sentence to a file, the printing itself slows down Python. But we can see it's doing it pretty fine. If you push Control-C when you have a long print thing in an ongoing program, that'll just stop it. So you can just say, you know, quit. I don't need to see the whole thing. It should be fine. We don't need to check till the end. Okay, and then we've done the web scraping. That's the point of the class. And then the last thing we'll do, we'll go back to what we did in the beginning, which is to take all this stuff that we have. We have this, we have the lines, and we have the title of not only a single fable, but if we take a look up at what this is inside of, we have all the fables that we found within the table of contents. So once we do this, we should be able to save all of them to this ASOP box that we have on the side. So let's go ahead and we can actually, like we've been doing, copy and paste the code that we had. Let's go back up. Now we want to save some stuff. So let's go ahead and copy this again because we want to save it to the ASOP spot. So I can put this again. Let me indent these. So my save path again in ASOP. My file name I need to change. So what can we call it? This time we can say it's going to be the title. We have the title in hand. One thing that I'll just anticipate is a lot of these titles, they have, let's go back to the table of contents. They have spaces in them. They also sometimes have punctuation, but I think that's not as problematic. But with file names, you'll probably want to take out all that stuff. So we'll want to take this title string, just do a little bit to it, not everything, just to make it acceptable as a file name. So I'm going to say take the title, and just as a demonstration, let's just take out the white spaces because I don't think you can make file names with white spaces, or at least you shouldn't. And say go in title, find all single white spaces and replace them with nothing basically. So just delete all of them. And then we just need to add .text to the end so we can specify it's a .text file. So we got the file name, we join them up. Let's go ahead and do this with open line again. So with open file as we just made it. in the W mode, just name my kind of file that I'm doing. And we'll go ahead and just now take all the data that we have from each fable and all of them and save it to its own file as we make them. So I'm just going to make it pretty simple. I'll do title at the top, put a space, put the fable text, put a space, put that block quote we found at the bottom. So I'm going to write my title. And then again, because .write does not explicitly put in blank lines at the end of each message you put in, we'll just put a couple new lines after title. Next, we'll do, we have to add the lines of the text. That's still a list, so we can't just write it. We have to loop those lines. So we'll say line and fable lines. And then inside, when we have access to each line at a time, we'll say add a line, and then also add a new line at the end, so they get broken up by some space. That'll be my fable line. So we've got 1 and 2, and then the last thing is just to add this, and we'll actually add a couple new lines above it, so it's spaced out from this. Now, when we do this, we should be able to see everything happen. This will be the last step in the class. And I'm just going to put a final print statement all the way at the bottom, all the way outdented, just to let me know in the console when it's done. Oops. Okay, program complete. That'll let me know, because it will take a small second, as long as we didn't have any bugs. So now we have all the data. We'll save it to a file, and now we should see, as we run this code inside ASOP, we should see a whole bunch of files begin to pop up as we execute this. So Python scrape.py, push go on that. Oh, I left that one print statement in, so that'll slow down a little bit, but we can see it's all getting added in. It's getting added in alphabetically, so it's kind of popping in randomly. We can see it's getting quite big. Still going. We'll just wait on that to end. Let me go find that print statement and take it out. Okay, now we got complete. So we know it's all done. Let's go back up to the top, and we'll just check a couple of these. Yep, so we got what we want. We got the title, some space, the fable text, some space, and then that block quote at the end. We'll just keep checking these. Looks all good. The Python program didn't crash, so that's good. But we'll just check to see, you can always find like exceptions. Maybe one fable was set up a different way, so maybe something might happen to mess with that one. But they all look pretty good. So that is all the code that we have to do today. So that's web scraping. It's pretty easy. We can see opening files and saving them as easy as it can be. Web scraping itself with Beautiful Soup, pretty easy as well. At least with this one, when you get to kind of big websites, you have to look, depending on what kind of data you want. You might have a web page with a table of stocks data, and then you kind of have to select the table and maybe specific columns and only specific classes of columns, all kinds of things. So the most difficult thing might just be the selection, how to specify exactly into only what you want. But besides that, it's not too bad. Let me open up, let's see. Yeah, so let's just skip to the end of the slideshow just to mention what's in it at the end. At the beginning, I have a bunch of links to all the websites that taught me how to do all this. So you can check out those to see kind of everything, because we couldn't talk about everything. But I just want to mention, we did Beautiful Soup. That's how you web scrape, just kind of a static site. You could web scrape like Wikipedia, any, this site, any kind of just site that's text. But if you want to access a site that maybe you have to do something with to get stuff, maybe you have to log in, maybe you have to click a button and then you can scrape stuff. To actually be able to do stuff with Python and then scrape, that's going to be a second module, which is called Mechanical Soup. And that lets you actually interact with the web page and then do that scraping. Instead of when it's simplest, you just get a web page, all the stuff is on it without clicking buttons and you can just pull it off. That's what Mechanical Soup can do. Obviously a step up in complexity. And then Selenium as well. That's also something to help automate things, pulling stuff from websites, clicking buttons on web pages, all that kind of stuff. So those two kind of go hand in hand when you need to do something with kind of a complicated website. And then the last thing, just some practice. A good place to practice is Wikipedia. You could scrape all the links off a given page, maybe download all the images. You can do that as well. It's not always just text. You can download images, videos, anything you want. So Wikipedia is good. This website is basically just a dummy website. So it has like a fake bookshop. It has a fake motivational quotes page, and it just has it set up so you can practice selecting things on a page. Because like we said in the beginning, if you try to scrape a site like Amazon or something like that, they might be able to detect you web scraping and stop you because they don't want so many bots taking up bandwidth. So that's a good site to just go to, which is a dummy website that exists to be web scraped. So that's good. And then, yeah, that's everything we had to do today. Let's do this. Let me just pause the video.